A warm welcome to everyone. This is Janyam Sushmita. I am from CSE department. Now I am going to discuss with you about applications of mathematics in crowd control. Now coming to the part of mathematics model and methods for crowd dynamic control. This paper aims at presenting a brief survey of some recent developments in mathematical modeling and control techniques for human crowd dynamic. Here we define crowd dynamic control as the part of a streaking large mass of people in the desired direction, minimizing a verbal directives to individuals and preserving as much as possible and their natural behavior. To extreme cases we get methods to streak crowd along a predefined paths without the crowd being aware of it. For example, individuals do not even perceive that their natural decisions are guided. Such as a control techniques are expected to be effective in all situations characterized by the impossibility of a directions communicating with the crowd. For example, in case of a large groups and a violence crowd following the directions indicating by even organizing of a police. Now coming to the part of a crowd control. Crowd control streams on different such as topics and behaves benefits from opportunities. First, physics and physiology are called upon to point out the main behavior aspects with the present the consistent ingredients of a mathematical model. Models will then be used to create a digital twin of the moving a crowd. Collaboration is particularly challenging considering the high variability among a person and the difficulty of measuring some parameters like pushing, degree of a rationality, knowledge of the surrounding events and the surrounding environment, etc. After that, we have to control the setup, the control problems defining that. Roughly speaking, this means that we need to identify which part of the system is subjected to the modifications. Crowd dynamic can be observed at different scales and the choices of the point of viewing disasters change the modeling framework. An approach consisting in tracking every signal agent including the position of toss and heads. A microphone approach consists instead in tracking each and every signal agent assuming is a zero dimensional point or a small circle. An approach is based on the description of average qualities like the density of people, but it keeps the possibility to desist one to one interaction. Finally, approach desires only average qualities, losing a kind of a gradiently. Dynamic can be observed at different scales, and the choices of the point of a view disastering changes in the model framework. The reset of the manuscript is organizing as follows. In Sec 2, we introduce the mathematical model for enhancing which will be server as a guideline for rest of the paper. Main ingredient and are introduced as the three scales of observation. In addition, we discuss methods to manage absolute in models. For example, how to prevent from entering a forbidden zones on the walking areas. In sector 3, we present crowd control techniques based on the use of leaders either visible or for example recognizing from the crowd as such or not. In sector 4, we analyze crowd control techniques based on the use of a smart absolutes located in the walking areas to modify the prescript and of the environment and suitable modify the optimal paths. Finally, in sector 5, we sketch some conclusions and further future research directions. Crowd common techniques. Construction bargates, using of weapons and projectiles, flaking action, participating in a verbal abuse, using of vehicles or other objects, setting a fire, bargate settings, etc. And the system of a self-organizing with a probability 1. P of AI is equals to AI minus 1 minus 11th collision was a line 1 is equals to half. P of AI is equals to AI minus 1 plus 11th collision was in line 1 is equals to half. Similarly, argument shows that P of AI is equals to 11th collision was a line 2 is equals to half. In the same way, line 2 also will be the same. As the consequences, we have P of AI is equals to AI minus 1 is equals to P of AI is equals to AI minus 1 plus 1 is equals to half, and K is equals to min. K is greater than P of K is greater. Direction of a predictable in each line after self organization. P of AK is equals to n of a naught plus n by 2 and number of collisions required for self organization. E of k a naught is equals to n by 2 minus a naught into n of a naught plus n by 2.